There we go. So welcome everybody. This is our third session. And for those of you that are joining us for the first time, because we have quite a few new people that joined us in the last round. So welcome to you. And this session that we're going to be doing will be on matter. And it's a pretty big one, a packed one for sure. So we appreciate you coming today. We know that you're heading into a long weekend and that you have all kinds of, oh, Angela. Okay. Ted, do you want to just answer Angela? Just tell her to maybe log out and log back in again.
I'm not too sure if she just got logged in or not. Angela, are you there with us?
I'm here now.
Oh, there you are. Okay, I see you. Good, great. Thank you. Good. All right. Okay, so what we're going to do is unpack this unit on matter for you. And again, I mean, within the timeframes that we have a limited amount that we can kind of share with you as far as the whole unit itself, but as best we can, we're going to try and really hit on those big concepts, the big rocks that would be there. So regardless of whether you're doing matter now or you weren't planning to do it until spring or after Christmas, at the end of the year, all of us would have hit those same big rocks and would have assessed those same huge concepts. So that's the piece that we really want to hang our hat on at the opening. We want to look at what are those skills and concepts that are going to be sitting in front of us. And then I'm trying to pack up as much in the way of resources for you as we can to give you some tools that you could walk away with if you're going to be doing this later, or you've already started and you're just looking for some additional resources. Okay, so let's get started. We're going to begin with our land acknowledgement. In the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse Indigenous, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. And wherever possible, I'm going to try and put some links or some pieces into our acknowledgement that links to the Indigenous side and view with the unit that we're studying, in this case, matter, and the respect and relationship that Indigenous people have with the land is incredibly strong. I mean, it's a foundation. So I'm going to play just a very short video for you.
The water is in this story, the origin of life. Talks about these women, grandmothers, that were asked by the Creator, which ones will come here. First one, Creator asked, he made that one the moon, grandmother. Second one, he made into Mother Earth. The third one, he made into water. That's the life. There's lots of life in that water. It's a woman, grandmother. The fourth one, he made into the image of woman we see walking around on earth today. That one carry life into this world for the Creator. That's where we're born from. And there's more to that. But for now, just so you know, for us people, what we're trying to do is preserve what we have. Canada's built on our traditions, built on our stories, because we were the first ones here. Everything that Canada is come from us. So if you go back to that story and know where we come from, the woman is strong, but today the woman's voice is taken out of decision-making processes in this system. That's why there's chaos. There's no more balance in that with respect to how the relationships go. That's what I was told by my grandfathers in my ceremony. We always hear this term growing up. What kind of a world are we going to leave for our children? Everything's being poisoned off. I ask, what kind of a child are we going to leave for the world? If we don't teach our children the proper way to respect Mother Earth, if we don't talk to our children and our grandchildren how to respect the environment, how to respect those birds, those animals, the trees, what kind of a world is that going to be?
Okay. Some powerful words in there, and definitely some strong understandings of their view of Mother Earth, and without question, there's more to unpack there. For the grade 5 teachers, they have an entire unit that could be done in wetlands, specifically through the lens of Indigenous views. And that was one of the things that we suggested to them that they do, because they're the only group so far that has had one unit that they're receiving students from, or that you would have received students from, for example, with the sacred relationships having the understanding of wetlands. So this would be another piece where we took that from. So this is probably not new to all of you, but nonetheless. So at the end of our sessions, we're always hopeful that you're going to come away with confidence that you have at least a little bit more in your toolbox, that efficacy, that I have the move forward and the ability to take what I have in front of me and hopefully mix and mesh what we're sharing with you as well, to plan a unit that you feel comfortable with and that you can take forward. We're aware of the fact that we're not always going to be able to give you resources that match everything, but we are definitely trying to give you a broad umbrella in each of the organizing ideas. So for grade 6, as we move forward, we have all of the units from here on in. Everything is going to be covered for grade 6, and we probably won't show this one again in the future. But there are some things that I'd like to unpack, and I don't want to unpack the understandings here or the whole document, but I do want to just look at the top line again, and just a reminder, because this leads very much into where Ted is going to go. Remember, regardless of the document that we're looking at, there's 3 different colors, and the top color, the darkest color, always houses the organizing idea. And the organizing idea spans multiple grades. And in this particular case, this organizing idea spans 7 grades. It starts in kindergarten and goes right across to grade 6. Same sentence all the way across 7 grades. And within that one sentence and statement, we find the big overarching concept that sits commonly between those 7. So when people say, well, are somebody going to do up the big rocks or the essential learning outcomes? The answer is no, because they're already there. We have them. We just need to make sure that we're all at the same time at the end of the year have found the same big rocks, big concepts that are sitting in those sentences, and that those have been our focus when we design our units, have been the focus when we're doing our assessment as well. So this is the piece that we really want to make sure that everybody is aware that we go through here and that we can find the concepts in there. And then we want to see, where is the concept that we find here? How does that outline or lay into the the guiding question, as well as the learner outcome that I have in my grade? So if you think of that organizing idea as a triangle upside down, the broad base is your organizing idea. As I start to get narrower down, I have the guiding question, and at the bottom, I have the learner outcome, which basically I'm unpacking for my particular grade. So just a couple of words again, and again, we won't show this one again. We just wanted to make sure that now we had some new people on. We wanted to just share the same slide deck. So for those who've seen it, bear with us. But when we see the word include, so in this particular case, a material's response to temperature change requires consideration when designing infrastructure, including sidewalks, bridges, and roads. So anything that comes behind including are things that we want to include in the teaching of our lesson. So they're sort of not the negotiable pieces. I don't get to make decisions. I can add to that list, but I want to make sure that sidewalks, bridges, and roads, for example, are included in my instructional piece somewhere, whether that's through exploration, whether it's through research, whether it's direct teaching. However you unpack that is entirely up to you, but it needs to be part of our instructional piece. If I go down to the bottom and I look at such as, I have a little bit more flexibility there. When it has such as written, whatever comes behind it are suggestions. You can use those suggestions, absolutely. There's nothing saying that you couldn't. Wood, biofuel, wind. So those are all the different kinds of resources that I could definitely use. But I can also add to that list, or if I live in a particular area where there's another focus on a resource, then I would absolutely include those. So there is flexibility in there. It's content. Sorry.
Chris, can I interrupt for 1 second?
Yeah.
When it gets to the parenthesized words that was reworded, I think if you refresh, you've got the old definition, old words on there. I'm not too sure if you refresh your slide, it may show up appropriate there.
It's okay. We would just add it
Sorry
in.
about that.
That's okay.
Here we go.
There we go. Alrighty. So we had a little bit of change in this slide because from the time that we got information given to us, and we had somebody yesterday from Edmonton Public who were kind enough to say that's not what Albert Ed was saying at the moment. So with the bracketed words now, what they're suggesting is that is for the teacher and for the parent. It is not a required term that you would necessarily teach to the child. If it's appropriate to and they're able to handle it, I don't see why you couldn't, but nonetheless, it's not a requirement because it may not be age appropriate for them. And so you might want to use the descriptor that comes before it as your teaching piece with the student. Okay, so minor change there. So with that, I'm going to turn it over to Ted, who's going to unpack our concepts that are housed in matter right now, and also those skills and processes that we need to be putting into our planning right off the bat, because that's going to help how we assess and how we unpack our unit. So take it away, Ted.
Thank you, Chris. And I just want to maybe begin with a little description of this slide here. As Chris mentioned, the idea of concepts is going to come up a lot when we got skills and processes and so on. And if we unpack this curriculum the way we maybe have unpacked older science curriculum, where we focus on words and vocabulary and facts, and just go through the curriculum as a checklist, we may not be doing what we, I think, want to be doing to help our students as they leave our classes and our schools. So as Chris plays this little video here of this robot, I'd just like you to think what it is that students do need to know and do need to be able to do that will carry them well into the future. Go ahead, Chris.
Oh, okay.
We're stuck on that slide too. That's not working.
Oh, good.
Oh, there we go. if you've ever seen any of the videos that have a little short clippets of the type of skin they could put on robots' faces as well, it really makes us wonder, whoa, what do we really need to have our kids know and learn? Because those computers or those robots that can move so fluidly and have such facial expressions that can show emotions on them are really, that's just the tip of the iceberg of where things can go. And so I'm going to present this front end part through a lens perhaps that you may be not familiar with, or you are familiar with, and it may be and you're just getting used to this way of looking at curriculum. But I think if we do that, we will find that we'll have a better chance of reaching those competencies that you list here that have been around for some time. That
Sorry.
But anytime you ask teachers want for students down the road and in the future, what they want is we want these things. We want our kids to be creative and wanted to be able to do research well and distinguish between what's fake, what's not. We want them to have good critical thinking skills and so on. Want them to be able to read and use their numeracy skills in a way that will help them in the future. So one of those things, our teaching has to flip those things. And the way we can do that is unpack the curriculum through 3 different lenses. And those are the lenses I'm going to take you with right now. The first lens is the lens of a concept. And you'll see I have examples of concept on the left-hand side. You're probably familiar with activity like this. It's a concept attainment where on one side of the chart, which is the yes column, those are all examples of a concept. And those things on the no side are not examples of concepts because they don't have what it takes. In other words, the things on the right or the left have something in common. What is it that concepts have in common? And I'm going to go through this a little bit faster than I would in a classroom because I would ordinarily show things one at a time and you have some time for kids to think, but we're going to be moving fairly fast here today. So there's lots to pack in here. So I do apologize for that. Anyway, when you do take a look at the words on the bottom, which of those would be concepts? Which of those words have those words that make them concepts? And if we go to the next slide, and if you thought that perhaps courage was a concept, yes. Christmas, no. Because concepts are these. Concepts are basically nouns that come in 1 or 2 words. If you go to the next slide, Chris, and they have certain attributes that make them what they are. And they can be shared across a whole bunch of examples. If we could think of a concept as a filing folder, and we naturally put things in file folders that have things in common, and as we make our file folders, you know what that attribute of that file folder is, whether it's finances or lesson plans or whatever, that's what goes in that folder. And that's essentially what a concept is. It's a way for us to organize ideas. So in the situation here, we have the ideas or the concept of vehicles, but we also have sub-concepts. We can break that down to cars and trucks because there's certain attributes of a truck, and attributes of a car that make a car a car. And as you can see, we have to make a third folder for that vehicle in the middle. And that may be a car truck. We're not too sure. It's an El Camino, if you're wondering. So that's what a concept is. And that's what we've often looked at those ideas of concept as the vocabulary in science. I'd like to twist that and say these are the concepts because they have some magic with them when you use those concepts and know what they are. We'll see how that's going to unfold in a second. So we do know that concepts can be very specific or quite general, and they can be more abstract in general than what we see here. And the more general the concept, the more able it is to other disciplines. So change is quite transferable across art or phys ed, science, language arts. And you could look at change as a concept through many different ways. Whereas something like ecosystem may be more of a science-specific concept that's going to stay pretty much within the discipline. Next slide, please, Chris. So what I've done is all the words are concepts out of the curriculum to get out of this organizing idea, to get a little bit of a sense of what is in this curriculum or this organizing idea and how we can make some sense of it. Because concepts are things that you can connect one another in different ways. And this is one representation least my way the organizing ideas put together. And you may want to read it something like this. I won't read through the whole thing, but if you follow the lines and the arrows, the particle theory of matter. In the particle theory of matter, we explained that temperature can change through heating or cooling, which causes a change in the particles, and they can speed or decrease. And that speed or reduction can, I'm just trying to see, my screen's kind of small, can create a contraction, or the distance between particles can create a contraction or expansion of the matter, and so on. And you just read the little words as you go along. It's a pretty broad, big idea of what we're looking at in this unit. Now, there are a lot of concepts there, and we have to cover all of them, but some of them, as you know, and Chris is going to point out to you, are the really big ones, and they're repeated in grade 3, 1, 2, 3, 4, 5, and all the way up to 6. And so as Chris goes through her activities, those will become quite apparent to you. Next slide. So now we know what a concept is. I mentioned at the start that we're going to look through this organizing idea through 3 conceptual lenses. And the first one is through the lens of concepts. When I talk about a conceptual lens, what I mean is this. If I was to ask you to look at this picture through the lens of the concept of resources, you might focus on a couple things. You might focus on the water and see that as a resource. You might notice the sand. But if I asked you to change that and look through the concept of location, well, you might think of it being a lake somewhere and all those ideas with the lake. Or if I asked you to look at the picture through the lens of you might have a different sense, a different picture, or a different focus, such as the texture of the sand or the coolness of the water. And then we can imagine some of those other senses, such as the smell of the lake and the feeling the wind blowing in our faces. So this conceptual lens helps us to focus on what we want to look at. And so the first conceptual lens that I'd like to look at is through the lens of concepts. And if you take a look at this, the organizing idea, we have the 3 cusps, or the 3 associated cusps there, and the learner outcome. And within those words are concepts, and you've probably seen them show up in the concept map that I had. But if you could take a moment and look through this portion of the curriculum through the lens of concepts, what is it that you see? Where are the concepts? What are Chris is going to press the button here to make the slides or the concepts magically appear on the next slide. And we can see there are a lot of them there. But you also see that there are many that are repeated. Particles, matter, solids, liquid gases. And you'll see those throughout. Properties is another word that shows up quite a bit. So a lot of those are concepts that have reappeared from previous grades as well. And I'm going to just go to the next slide, because there are some concepts that are hidden in that will become useful to investigate as well along the way. For example, if you're are doing words, I guess, and the verbs have associated concepts with them. So if you're going to investigate, you're going to do the action of investigating, you are completing an investigation. If you analyze something, you're going to produce an analysis. So on. If you're going to hypothesize, you're going to create a hypothesis. And so if students can understand what those concepts are, for example, what is a description or a demonstration, they're better it's easier to teach them the skill of, here's what we do then for a demonstration. Here's some things you have to consider when you do that. Here's an analysis. Here's some things you have to consider when you do that. Now, that's a lot of concepts. So as I mentioned, there are ones that are the big ones and ones that we keep coming back to and hammering. And those are, in this particular organizing idea, is the phase change, heating and cooling, thermal expansion, and particle model matter. And you'll see those words or related concepts show up in the guiding question as well. And so those are the ones we want to take a look at. So those are generally the main concepts within the curriculum. We have to look at those, but we want to focus now a little bit through and look through the curriculum skills. And if we can go to the next slide, Chris, I'd like to take a look at the skills or the thinking and the doing verbs in a slowed down fashion as well. These are all the things the knowledge column has those, and the understanding has the key concepts that we're going to pull out. And the skill of procedure column has those key. And the first thing to do is try to figure out what is the doing word when you look at this. And you'll see that I have them highlighted there. And once you hide them, you'll notice that there's a certain structure to all these skills and procedure statements. That's the next slide, Chris. Yeah. You'll see that the front end is that verb. And the second part is that knowledge part. And it's important to keep those separate. And I'll explain why in a second. So once you've separated them out, the knowledge part versus the skills part, then you want to clarify some things. That's where we get to that slide there, Chris, the next one, or the bottom menu. Sorry, yeah. Geez, have we got the right? Yeah, so some of these verbs you'll probably find if you've been working with are problematic in some ways, or you have to stop and really think about them when you are going through this. Let's take a look at the first example there. Explain phase changes using the model of matter. Well, the skill is to explain. And I think we have to stop and tell kids, what do we mean by explain? What's a good explanation? What's involved in explanation? Let's practice explaining something so that they understand what you mean by explanation and how that can be. It could be using diagram, concept map, and there are various ways to explain. You could keep on the left side there, Chris.
Okay.
Yeah, just move it over if you can. Same with discuss. In the second column, discuss the connection between movement of particles and temperature in degrees Celsius. Once again, a discussion and being able to discuss can be a very powerful learning tool, but you'll want to make sure that kids are good at discussing before you give them some task to complete that's content related, so that they're focusing on the content more than the skill. So we know that, and that's what I have in the clarification. And so if you can make it clear to students, what is a good discussion? What do people do when they discuss? You can have them self-assess themselves about how they participated in the discussion, or you can give them some feedback about what you noticed. And when we talk about a discussion, don't forget, we're not just talking about sitting and having a class discussion, but there are many things that you can do in a discussion, such as the four corners, jigsaw activities. There's discussion happening in there. Think, pair, share. So those are ways that kids can discuss, but you'll want to make sure to have them practice discussion and give them some feedback on their discussion without tying it into the course content. Don't worry about that last column. It makes sense. I may come back to it later on. But the problem with some of these skills and procedure statements is you'll see that if you go right to that, have them do that without having them know the knowledge, it's going to be hard for them to hit the mark. So please don't do that without making sure they understand the concepts related to it, such as the particle model of matter and phase changes. Make sure they're very grounded in those before you pose that question to them. And I'll explain that in a little bit. So on that slide that Chris is at, just gives some things to consider when you're doing. If you scroll down a little bit, Chris, there are some that I think we need to get some clarification from. For example, the word relate there, relate the melting and freezing and boiling points of water to degrees Celsius. Making relationship is a little bit more than that, I think, and it may just mean just to state. That was also done in grade 5, so I don't know why it's repeated there, where students identified the melting and freezing points of water. So that's a one that would up and to make sure we understand with more clarity. Same with describe how a thermometer works. Throughout the curriculum, the word explain would show up here instead of describe, because in the other grades, describe has a particular meaning. It means to use your observations and measurements and tests to describe something. And so describe how a thermometer works would maybe maybe is the wrong word. Maybe the better thing is to explain. And same with design. If we're going to have kids design their own thermometers, will need a lot of background knowledge for sure. I'm not too sure if Alberta meant to replicate or to create something for, because to create their own thermometer could be a tough order, but it's doable if they're really grounded and they really have a strong knowledge of all the concepts related to this. And so you can have you can go through the rest of the slide later on. It'll be in the folder that has all the documents. It has some considerations to think about when it comes to skills and processes. So just be aware of them, focus on the skill on the front end of that statement, and make sure that they know the content part of that statement before you have them do that entire skills and procedure statement. Next slide, Chris. And so after going through the steps and after going through the skills, we'll see that there's some key anchoring concepts and some key skills, which are evaluate, investigate, experiment, discuss. Those show up through a lot of the skills and procedures comments. So those are the ones you'll want to focus on a little bit. When it comes to experiment, I have a link in that slide that we just came out of. It's that spreadsheet. There's a link that'll take you to all of the definitions that I think that you need to know by grade 6. It explains what the steps in investigation. It explains the difference between an experiment and a simple experiment and a more controlled experiment. So once you're in that sheet that I showed you, it'll take you to a link that shows all the things that kids at grade 6 need to know about experimenting and what's expected of them for that grade. So we have to move on though. The third thing that I'd like you to do is look at this organizing idea through the lens of the learning process. Hattie and Fry and Donahue came up with this surface deep transfer phase of learning, where at the surface, this is where we get kids to really understand the knowledge and the basics at a good, strong level. So at the surface level, we want to make sure they understand that the concept of phases and the states of matter. We want them to understand what matter is, what a property is, and be able to transfer that around. We want them to understand how to compare and contrast, how to evaluate, and all those steps, and being good at those particular things at the surface level. Once they know that, then they can start making connections between things. That's where they start making connections between things like an experiment, an observation, and a description. And they can explain how that works for you. And once there's that deeper understanding, we move into the transfer part where they can apply their understandings to new contexts. And we'll look at a couple of examples here shortly. Now, if we layer over top of this our current science curriculum or this new science curriculum, you'll see knowledge and skills and processes are really working at that surface level. On the knowledge side, you have all the meanings of all the concepts. It's the knowledge. This is what they need to know. But they need a solid understanding of those. On the skills and process part, if you take away the content part and just focus on the verbs and that skill, something as well, that they need a deep surface level understanding. How do I do the skill? What is evaluation? How do I do it? What are the steps? We teach them those things at the surface level. And then once they know what the concepts are and have a good solid understanding of the individual concepts, and they're good at the skills, that's when we create activities where we put it together and we can ask them certain things to help them demonstrate their understanding. And we're going to go through some examples right now what I mean by that. So next slide, please, Chris. This is another way to explain, I think, what we're trying to get at here. There's that knowledge, which is at the surface level, the skills minus the content part. So conducting a simple experiment, how to do an experiment independently, that's the surface level. What is that? And what is volume? What is solid? And you put them together to create an understanding, and you give students experiments or activities to help them develop the understanding that bodies will stay in life in the winter due to having unique physical properties. So they do work together, and you ask them that question after the experiment to help develop that understanding. Next slide, please, Chris. To work with students and to help them understand things at the surface, and we have lots of instructional approaches. And if we were to again reorganize those at each of those phases of learning on the next slide, there are certain things we can do to help students understand things at the surface level, really get them to that understanding at the deeper level. Will move us into the transfer activities, which are the case studies, the project-based learning things, those big unit end things, where they take all the things they've learned and understood and go through this larger project together. But we have to be intentional. Not that we use that link, I don't think, Chris. It's on the next slide, but we have to be intentional of what we do here. So know where your kids are at. Are you working at a surface level, or a deep level, or a transfer level before you choose your activities? With the assessment part, this is where an example will prove best. So Chris, if you can click onto that sample assessment. What I've done in that top white part, or that top row, was taken some part of the curriculum out, which is this design of temperature tools, including thermometers, is based on the expansion and contraction of matter. And you could see the reigning knowledge, the understanding, and the skills and procedures part. So if we were just to pull the knowledge part out, really the thing is, we want kids to know what a thermometer is. And we want to make sure they understand that matter expands and contracts at different temperatures. So if I was going to teach to that, those are the things I would teach to. I would, at this point, ignore the thermometer, what the thermometer does, because that's already sort of getting an understanding part. So if you take a look at the instruction of how I might work at the surface level here, I would want them to demonstrate various thermometers, how to read them, what thermometers, and so on. What is thermal expansion? Give examples and have them develop that. Because I know that, look on the left, they're going to be evaluating something. I want them to understand what an evaluation is. And there's an example there. And in evaluating, you're going to be using criteria. So what are criteria? On the right at the surface level, well, I'm going to want students to know how to evaluate. Because if you scroll up for a second, Chris, that's really the skill, right? They're going to know how to describe how a thermometer works, design, and evaluate. I'm going to focus on it because that's really a skill that I want the kids to know. I have an example there of how you may want to introduce that. And it's really teaching skills directly that we're looking at. And then when I know they're good at evaluating, and I know they're good at understanding the things on the knowledge, then I'll go in the middle, and that's where I'm going to do that, and create a thermometer and then evaluate the effectiveness. They know how to evaluate, they know how to do the other things, they know what a thermometer is, so they're going to design one. And then comes the assessment piece, all right, which is down below. So they're going to have these thermometers, evaluate them, but how do I know where kids are at? Well, at the surface level, I'm going to ask them to give examples of thermal expansion before we even go on to that middle activity. Distinguish between comparing and contrasting. So I'm going to assess to make sure they understand all the things in knowledge. I'm going to assess them to make sure they know the steps. And I'm going to have them practice evaluating with other things before I have them do that comparing activity. And now they're good at that. I can give them that design the thermometer activity and evaluate, but then ask them that question. How does the particle model and help explain how a thermometer works? Now, when you answer that question, when you scroll up to the top, you'll see their answer will reflect the understanding. So if they can take their knowledge and skills, do something about it, and answer that question, they're going to be able to answer that question using their understanding from that activity. Oh boy, hope I haven't left you. At the end of the day, what we need to do is be be very thoughtful and just work at getting those kids to understand really deeply at the surface level, their skills and their concepts, and put them together and have them work at it so they can get a deeper understanding of the ideas and the skills involved. Next slide, please, Chris. To help you with that, again, you can go back to the other slide. You can go back to one there, Chris. So there are some questions to help you along the way. There's the knowledge and skills questions. Like if you're wondering what activity or what you're going to do is going to help answer one of those questions under the column there, you'll know where you're at with the kids. So if you're going to ask them to state the meaning or definition, you're at the knowledge and skills. Asking to show a relationship between the ideas, like making a concept map, or asking the question, what's the connection between an observation and a description? You're working at that understanding level. And if you get them to apply it, like you may even want them to get them to design a thermometer, well, now you're getting to the apply level of those activities. So once you use this as a guide to decide where you're at along the learning curve with the kids and just help decide which activities you might want to use. And finally, next slide, Chris. That's where we ask you to be intentional about know where you are, choose activities purposely. So this goes through she's got a vast range of activities to share with you and resources. That's the third lens we'd like you to look at. Which of the activities that Chris is going to share with you and resources would work well at the surface, which would work well at the deep, and which would work well at the transfer. Slide. And if you would like, there is a planning tool that might help along. Some of you may want to look at this. All it is just a sheet that has certain things to it. It's got a drop-down menu of the different. It's got a sense of all that I showed you earlier. It's got the different drop downs of the different knowledge, understanding, and skills and processes that can help you out. And the bottom part is broken down into, the bottom half is broken down into the competencies, because if we get one of our learning activities to have kids practice those competencies, that's the only place where they're going to really get to learn them. So we can't go through a checklist approach. We have to use a variety of teaching and instructional strategies that we know can help hit those competencies. This part can help you pull out the concepts you want to work on and a place where you can define them, and always handy related to this learning outcome. All the key concepts that were in that concept map are listed here. And same with this, the key skills down below. The next section is to help you keep them organized. What are the key skills that are there? What are they? What do they mean? How are they defined? And then the next section is just how you can maybe organize your learning activities into surface, deep, and transfer activities.
Are there any questions of Ted?
Maybe a question, boy, what was that all about? Just give it. Sorry, I did go very fast. I know an hour is really, or half hour is not really much to.
No, and we're finding, both of us are finding that it's hard to unpack this for you in the time that we have, for sure.
It is, but I think the big nugget here is that, you know, and Chris is going to help with that. What are the big ideas, the big concepts? What are the key skills we want to develop? And just keep in mind that we want to develop those to really get to that real deep understanding that is really where we want our kids to be. So, Chris?
Okay, I don't think I linked it, so I think I'll just stay with this one just to be on the safe side. So, as I mentioned at the beginning, what I'd like to do is share what we're hearing from most of the teachers, and we heard it again yesterday in the group, was, you know, that just getting some resources in my hand is really helpful, because I don't have A, the time to find it, but B, I might be new and I'm not sure where I'm looking for, and those types of things. So I'm sharing oversharing. I mean, what I have here for you is definitely not the amount of resources I would expect you to use. That said, personally, when I go in and teach something, if I'm teaching a younger group, an elementary group, I sometimes will come in and give them, you know, if it was a quick YouTube in the morning and they would get their first introduction to something, I might review it, but not with the same YouTube, a different one or a different story or a different printout, just so that they're getting the same information, but from a different medium and a different perspective. And there's always something new that's usually entailed in those as well. So we're really looking at that thermal and particle matter and how those connect together. But as Ted said, what we are finding is that there's a ton of overlap here. The boundaries between the grades are not clear. And so there is definitely carryover from one grade to another. That also said, you no longer live sort of in your own world of a topic of science in grade 6. It's not beginning to end. And that in itself is a little bit different than you've ever had to experience in science before, because now we have to be cognizant, as we would with the math, that there's going to have to be some bridging that happens here as well. Because these students that are in your class this year did not have the benefit of grades 4, 5, grade 3, 4, 5 in the new curriculum to bring forward some of those key concepts that in the real world, if they had done that, they would have those in their back pocket already. So we are going to have to be intentional, if you haven't taught matter yet, to go back and find out first where they're at. What do they know? How far do I need to do a little bit of tweaking to go back and just pick up some of those key concepts, not reteach all of those grades, but there are some really key pieces that are foundational for all the grades that the kids need to know. And if they don't have that background knowledge, then it's going to be futile to start jumping into some of the concepts we have here, because their connections just aren't going to be there. At the best they would be is just a straight memorization of some term that you give me, but there's no understanding that's going to happen with that. So keep that in mind, because that is what makes this curriculum a little bit different in science than we've had before. So we are really looking at heating and cooling effects. I mean, in whatever we want to define them at, that's what we want to see, is unpacking that whole piece. And can they model, can they describe, can they show us after an experiment how all of that ties together? And it's not, again, just a specific, you know, I've got this 1.1, 1.2. That's not how these are going to work, because they all blend together. And you actually can answer a number of the skill questions that are in the curriculum that Ted actually already pointed out to you, could, depending on how you set up your unit, become your transfer questions. So it just really depends on what your starting point is going to be. I've included some things from the grade 3s. Now, remember, when you go into the science folder, you have access to all the grades. You're not just restricted to your grade. So if you're seeing some things here and you're feeling that perhaps maybe I need to check that, or I played this video with my grade 6s and there was a lot of never seen that before, then you might want to go back and grab a few activities from grade 3. You're not going to reteach the whole thing. But what was key out of grade 3 were those states of matter. Do they know the 3 states of matter? Like, that's the starting point, the foundation of everything that we're starting to go through right up to grade 6 right now. And so this little video of all the ones that we did in grade 3, this is probably the best one if you just want to even play it as an opener to see where they're at if you haven't started matter already. And the nice part about this one is you can actually stop it, because there's some open-ended questions that they throw in there, and you could just stop it and say, how do we answer that? That'll also give you a great formative assessment to find out where they're at and what their thinking is, and how quickly then you can proceed with that. In the grade 3 section, I also provided them with a card sort. I did a foldable for them, but that's neither here nor there. The card sort was based on the video that I just showed you. And so we asked them to simply listen to it. We didn't teach them, we didn't suggest teaching them the states of matter, or 3 forms of matter. We just simply said, let's watch it and let's learn from this and see what we remember. And so these are some of the key pieces that came out of that. And they just simply did a card sort based on, is it a solid? Is it a gas? Is it a liquid? If you're finding that they could benefit from a little bit of work in there. There's a blend between demonstration and activities. So hands-on activities or fill in the blank kinds of activities like a worksheet or a demo that they can watch. If they need a little bit of backup, just refresher on some of these areas. These are all hyperlinked underneath, and the colors are over here to give you the description of what it is. So if there's something there that you feel would benefit them before you move forward with into a higher level, then by all means. From the grade 5, there were some pretty key pieces in there, and they are absolutely directly related to grade 6. So they would not necessarily have arrived at your doorstep knowing these terms or being really versed in them so that they can do an application. So I need to know mass, I need to know volume, I need to know density, because those are comparatives that I'm going to be doing in grade 6. These videos could absolutely be the beginning of a grade 6 level as well, but they fit well into some of the things that were happening in grade 5 as well. So there's so much crossover here between these two grades so that you need to be really cognizant of where they're at and where they're going to be. So again, I'm giving these to you as just hyperlinked in here. Compressing solids, liquids, and gases, these are at the bottom. So again, and these are just models, or sorry, demos that just show them, and you could easily do them, even if you don't have a lot of science equipment in your classroom. You can easily just grab a syringe of any kind and just hold it against your hand and push on it with air and just to model those things. But this is really the kind of foundational piece that's important for them to get into matter for grade 6. Now, these are probably all going to want to start. Come on, let's go. There we go. So moving into grade 6, then, I'm going to assume that we have all of those sort of in our back pocket. You're going to be able to use some of them again. But as I was unpacking this unit, looking at, again, knowing what's grade 5 already, and in a real world, had they come to my doorstep with all of that, I might just leverage that and kind of divide this up into sort of 3 sections, not 3 separate units, but 3 sections that kind of flow from one into the other. And the first one would be talking about those phase changes and how does heat directly affect my phase changes, so the thermal expansion. So you might want to talk about how temperature affects particle movement, because they just learned in grade 5 about the different structures of particles in the different states of matter. What are the phase changes? And they do talk about that a little bit in grade 5 already, but now we're really leveraging that because that's what we're looking for. Include volume changes. Mass remains the same, volume can change, right? So if I freeze water, I can see it overflow. If I put too much water in and I put the lid on, and that's a good experiment for them to do, is take a plastic Tupperware, put some water in it, freeze it, and then watch the lid pop off because the water has expanded, right? So that's something we can do. And goodness gracious, with the weather that we have right now, it's perfect. We can just stick it outside and it will do what it's supposed to do. But in here too, we also have that thermal expansion, and there's the requirement and the discussion about, can you experiment? Can you explain? And it could be a demonstration that they're doing an explanation, or you're going to do a demonstration and now they're going to give you a description of what they've learned and how they're tying some of those pieces together. So I'm just giving you some ideas here because this is really going to depend on the tools you have available to you and how you typically would do an experiment in your class. I'm cognizant that not everybody has access to a lot of resources. And so a lot of the things that I've got for you are demos already, so that if you don't have the tools readily available, you can still do the demonstration experiment. It's just going to be done on screen, and then we still have the same conversations. We can still do the same scientific methods and have conversation about it. The water piece in the middle, water, the fantastic liquid, is kind of what I would call it. That it shows up in all 3 phases. Again, we can see that. I have demos. If you don't have a hot plate that you could grab and do some work with that, they can run outside right now and just put a cup full of snow into a container and bring it in, right? And have the conversation of what that would look like. But also, how did water play a role in how we developed our measurement scale, our temperature, our thermometer? And that magic number of melting, freezing, as Ted said, is in grade 5, but it comes up again when we talk about the development of the thermometer and those pieces. But how do they read a thermometer? Most students in grade 6, we would think that they would know that, but it would be like money. I wouldn't make that assumption because they may not ever have seen a thermometer. They might not have one at home, right? There might just be a digital thermometer on their house that reads off what it is every day, but have they actually read a thermometer? And keep in mind that in grade 3, we do imperial and metric. So they are reading, they're not converting in the sense of using any kind of formula. They're as simple as, could you take a ruler, and if I said to you, what would 20 degrees Celsius be in Fahrenheit? That would just be a read across. And that would not be inappropriate because most thermometers right now that we have both of them on there. And kids travel a lot. They live in a world where they live quickly and they travel from one world, a section of the world to the other where we see both sides. So that wouldn't be a bad thing for them to have, but that's not the focus. It's not, Fahrenheit isn't the focus for sure. Design their own. So again, being cognizant that there may not be enough tools available, I have a demo for you on how to make one. But it's on the simplest stuff that they could go home, get a pop bottle of any kind, just a straw, just need some plasticine that you can go borrow from kindergarten to grade 1 and make this. Like, it's not a hard thing to do. And now that it's cold outside, it would be very easy just to set it outside of their window or outside of your school doors, have them just label it and then just bring it back in. And now I can see the difference between the outside, what it's reading, and then I bring it back in the classroom. So it's not a big ask for an experiment, and it's very hands-on and very easy for them to do. Density and volume of water, I go back and revisit this in here as well, because now we have the ability, like I said, go out and freeze it. And then have that conversation about, now that I see it frozen, and sometimes I can see it frozen, and if you don't leave it out long enough, the bottom is still liquid, but the top is frozen, right? How does that link to one of the skills and procedure questions that are in there about animals that live in a pond, right? I can take that section that I'm supposed to explore and actually make that a transfer question. Because if I understand this properly, then I should be able to apply that to answering that question. And to me, that would be a really logical, I wouldn't want to teach a lesson just on fish are alive, because I mean, I would want to hope that after I've gone through these 2 sections, that they've already come to the conclusion that that water that's frozen at the top is an insulator of heat, right? And that's how it's basically keeping the fish on the bottom and the water still fluid. Why is it? Another question would be for those kids, how many go ice fishing? Why can you go ice fishing? If there's a foot of ice on top, why isn't it frozen all the way to the bottom, right? And how come they're not dying and suffocating down there? The last one would be kind of my third area would be location. And that would be more to combine what they've got over here and think about Alberta. Think about the challenges we have about doing construction, right? If you listen to the news, you hear about them saying, oh my gosh, it's construction season and we have to leverage it for all those 3 months or 4 months that we can, because it's a limited time in which they can go in and do things before it becomes so cold that the product that they're working with isn't going to be viable. So how do they decide what kind of concrete they're going to use? How do they decide what they put down on the ring road around Edmonton, for example? And this too will vary in wherever you live. This is going to be a very different conversation if you are from down south, where it's typically is much warmer, usually, to when it's up north and much colder. So how are those products different? What kinds of plastics survive being outside in wintertime in Alberta versus things that we don't leave outside, right? Because they would crack instantly. So having those conversations, that's really what this is all about. And again, I provided you some places that, or some videos that you can show them to start prompt their thinking. But then I'm only giving suggestions of sort of the things that were even in your curriculum, but what else would there be around your area that would be a consideration? There are some things that you can't, when you're doing cattle, for example, you don't have just any old bin outside. I travel down Battle River Hill all the time where I live. And in summertime, they just have a children's swimming pool. That's what they fill up with water for the cattle every morning because there's no fresh water for them to go to as a creek or a pond or whatever. And so they fill that up. Well, clearly that's not staying in winter. Well, why not? Well, because the first time it freezes, it just cracks and there would be no way to keep the water in there in the future. So having that conversation again might be more realistic for a child who's in that situation. So letting them choose a little bit about what that looks like. So considerations about sidewalks, roads, bridges, metals, gates, plastics, containers, all of those pieces all have to deal with thermal expansion and how they get treated. So to that end, you will find, for example, on this page, I matched it to the first thing I showed you, which was phase changes and thermal expansion. So here are some videos. Again, I'm not suggesting you'd use this whole page, but I will unpack it for you very quickly. So that's exactly, I've just put the titles below them or so that you have a sense of them. They're both a little bit different though. And so again, I could use one day and one the next day as a follow-up if I just want to refresh my memories or I just need a little bit of a refresher there. Everything that's in the middle here are experiments or demos. So if you haven't got the tools in your classroom to do some of the things that we were talking about, especially when you're trying to do time lapse and you're trying to measure the amount of time it takes for the ice to melt and you want to see that happen, then sometimes this is a nicer thing to have. So these in the center are all demos that you can access. And remember that if you're using the video, we still need to have that conversation about safety. Like if I was actually doing this, what would I have to have on? I'd need to have tongs to hold something hot. I'd need to have glasses on so that there's no spray. Like just making sure that we still do that scientific method and safety that would go along with it. Over here, again, you've got some links. I'm going to go to these two just very quickly so that you can see them. Now, some of these will have ads in them, but if you can get past the ad pieces, Thought Company is always a really good place to go because they do have some really concise information. What I liked about this one is they had some nice realistic pictures that you could absolutely have that conversation about. So if I've been working with the students already, could I come in and just bring this diagram up and have the conversation or discussion? What is happening here? Using vocabulary of science that we've been working with, right? So let's have that conversation. And they have lots of good ones, making ice cream, right? Having a gas and so on. So this goes on for pages and pages. And I'm not suggesting that you'd use everything, but there's lots there that you could use. Chem for Kids is another great one. And again, if you can get past the ads here, I'll just do one page because they come up again. But in this particular link, you actually have, and this is kind of a heads up, you have all of the grade 5, a little bit of grade 3, built right from the beginning here, what matter is, all the way through to beyond what you need to do. So we would probably stop right when you go through evaporation. All of these are put in a nice order. It's just continuous and it goes through. The diagrams are great. The questions they ask are great. It just goes beyond what we need to go to. But if you're looking for something and you're realizing I do need to do some backing up here and some bridging, this might be a good location for you. So again, I'm just giving you options. I'm not suggesting that you're going to dive into every one of these pages. You kind of need to figure out what it is that you need to add to your toolbox. PBS is another, I'm not sure if you're familiar with it, but PBS offers, Public Broadcasting System has a section for education, and they have umpteen hundreds of videos and interactive opportunities in there for learning. It's free to join. It doesn't cost you anything. You just sign up and you're free. If you sign in, it just gives you more activities and it gives you the teacher access. So teacher plans, teacher quizzes, as opposed to the student one. You can also download Google Classroom. You have that ability in there. Like it's quite a powerful little piece. So I do go there a lot for two reasons. One, they're very concise. They're usually 2 to 3 minutes max. And it's just, here's the topic that I want to talk about. Let's look at it. Let's look at a demo. Let's explain it. And then I can go back and still do some activities with the students with a little bit of knowledge right up front. In some cases, they have an entire unit. So in this case, they have matter, the phases of matter, as an interactive unit. So it will have interaction in there, that which means usually dragging and dropping, matching words, quick quizzes. They're all self-marking on there. But again, always look through and see. I'll just show you the one. And if you don't want to do the whole unit, not a big deal. But this is the start of the unit. You see here that you've got some, when it talks about phases of matter, what the teaching tips are. It'll give you the information that you can download, vocabulary for the kids and so on. And it just keeps going. And then they have videos that go along with each one. And then either it'll say in here that it's a video, or it'll say that it's an interactive, which means that the kids get to drag and drop, those kinds of things. And here's your info so that you can share it to Google Classroom. So if you have kids that are sick at home, you can just fire it off and they can still be part of what you're doing, right? So that's the nice part of it right now. If you don't want to do the whole thing, I did isolate the videos that are in there that would be most relevant to the unit that you're teaching. And those are found right below here. So again, it's up to you how you'd like to do that. There's another complete unit on heat transfer, same kind of a setup in there. If you don't want to do that, you can just do these 3 here as well, or 4. Another set of information or sites that you might want to use, it'll say grade 5, but remember that not every province and state that does math or science does it in the same grades that we do. So Science Matters is another great place for resources for us to go and get things. So in this case, it says grade 5, but it's really our grade 6. And what you have access to is everything that's here. So they put them into folders for you, and there are formatives in there. Not all the formatives would I use. Some of the there's some self checkers, which are really nice for the kids to be able to give you feedback on. But anyway, you do have a number of them up here. You're not going to go all the way, probably not going to go past the formative number 2, because then we're getting into mixtures and solutions, which is beyond what we have to. But this is a great little site. And I would check this out, even if you're not going to use them all, because there are some nice little, maybe isolated ideas that you might want to use, even a worksheet, even one of the formatives. And I would even say to you that some of the formatives could be rewritten into a transfer question, depending on where you're at, but they're actually quite well done. Okay, let's move to the water. So with water, we've already done the thermal transfer. We already got how water is involved in this, how heat can change it. Water's been used in that first section umpteen times as an example as well, right? And that's why I say this is not an isolated, it's just kind of a carryover that you're going to do. And so we could now talk about, well, we've got water and we heated it. How do we measure it? Like, how do we get the temperature? So again, reading, how do you read a thermometer? I just put them in there again. If kids are at home or you don't have the tools, then we could do it just through here. Talks about Fahrenheit and Celsius in there. I can tell you that right now. I even put a piece in here about infrared thermometers. And although those are more about the temperature of the body, I think a lot of our kids need to know how those work and what they are all about. And so that's just a sort of a sidebar that's there. Measuring water temperature, again, there's another video that you have here. But when I talk about the density and buoyancy, because that also came from the first part, if I revisit it here, then could I not ask the question, how does my knowledge, and after we've done some unpacking here and we've done some work with them, how does my knowledge of this help animal life in a pond survive in winter when the water is frozen on top? Right, that's one of their, it's actually a skill that they're supposed to, skill and procedure that it's supposed to unpack. And I guess when I read that, I thought, why would I unpack that? Why wouldn't I make that my transfer question? Because if I've got it, then I should be able to answer that question for you. Just a thought, okay? It's not saying that's the only way to do it. And then here's how do you make a thermometer. So if you've never seen one in action before and you want to just show it to them first, and then they can learn from that to make their own, and then they can try it out. And then they should be able to explain also why is their amount going up and down? Like where is the change in temperature affecting their particular thermometer? Don't forget the senses, right? Some people will say, how can you change the temperature of water? I could put my finger in and tell you which is colder for sure. I can feel it, that it's frozen. I can tell you that it's hot. So, I mean, if I don't need exact temperatures, the senses is definitely one that I can use as a measurement of temperature. I don't have to get really super fancy on it.
Kaylee. In this
So you've seen it all, you've actually...
They're all wanting to get started here. So then let's finish up with location. I want to build, I'm an engineer, I want to see the world around me. You might live in a small town, big city, it doesn't really matter. Does your small town have sidewalks? And if so, what are they, how are they designed? Some of them are made out of asphalt, some of them are made out of concrete. Do they have cracks in them? Do they have cracks in any of the sidewalks or at the school, right? So that's the kind of thing we can start to make them aware of. But in here too, it'll show them that when they go, maybe they've never even noticed it. And that's why I put in here, look for expansion gaps. The next time you go under a bridge, go watch for them because they're there. But most people just drive under the bridge. They don't even see them. They don't even recognize that there's a gap in there for a reason, right? Or railroad tracks, same thing. Or metal bridges. They have a leeway in the metal there as well. So some of these are unpacked for you in the 2 videos that I have. And that gives them a little bit of a chance to have a look at that. The YA class is another site that you could absolutely go to. It gives you some examples in here. If you go a little deeper into this, it actually has lessons for you as well. When it talks about marking the assignments and whatever, I caution you that that's a cost. So if you wanted to use that part of their program, you're able to go in and use everything for free, but if you wanted it marked online, then you would have to pay for that. They're just short little quizzes. They're again, go beyond what we need to go in every one of our sets, so you wouldn't do them all as you go through. So lastly, one of the things that we also were looking at and we talked about before was, what else do we have available to us? And right now, if you go to the website for science, you don't have any resources listed there on Learn Alberta. We do have a contract for the math with Gizmos, but with the math contract, if you can go into the LearnNet or Learn Explore site that they have, rather than just to the Learn Alberta site, you actually can access their science Gizmos as well. And so I just want to share that with you as well. There are a number of them that are available. I'm going to go in and just show it to you. And if you're saying, how do I get it? I will explain that to you as well. Yesterday, we had one of the reps from Gizmos Explore Learning came on with us and signed up the teachers. We couldn't get somebody today, but nonetheless, I just want to show you where it is. So I've already gone through, I've done the browse. I'll show you what that looks like in just a second. You can go in by grade. And what they've done is already linked them to the new organizing ideas. And in most cases, they're not outcomes, they're skills and procedures that they've linked them to. But they do have a number of gizmos that we can use. And if you've never used a gizmo, it's an interactive worksheet. It could be a lesson in itself, but it would say, what would happen if I put a big ice cube into this water? What would happen to the temperature? And the temperature, the thermometer will be in there. And with the gizmo, we can track what the temperature changes. So again, it's like a demo if I don't have one in the classroom. But the nice part is I can change the size of the ice cube. What if I wanted a massive ice cube in there? What would happen? Or I just put tiny little ice cube in, right? So just letting kids play and find out what happens when I change the conditions. Okay, so let's go to what this looks like. When you come in to sign in, and I'll give you the info to how to get a login, you can search by curriculum, and this is what comes up initially. And it looks like science should be here, but remember, we're in a new science program and it's a little bit tucked away. It's tucked away in the bottom right-hand corner, and you'll see Alberta 2022 draft curriculum. This is actually Alberta science. They should have science on here. So you just click on grade 6, that's what I did. You can select what you want, physical science or chemical science or whatever you want, and up it comes, right? So I can see the different pieces that I'm involved in. The numbering, when you see it, does not match. This is their numbering for the US and for Gizmos, the Explore Learning, to identify each of their outcomes. So what I did is I took this sheet for you. I did the same for grade 5 yesterday, and I retooled what you're seeing on the sheet of 6111 is really our 6M 1.1. So if you're using the numbered outcomes, I've gone through and renumbered them right beside it so that you can see how that links in. So this is the ones that are available. And there are some that are listed there underneath our skill. that are definitely not ones that match our skills. So I highlighted them in red. Don't do those because they do not fit with the grade 6 curriculum. So you'll see that we have a 1.1, 1.2, we have 1.4, 1.6. Not everything is covered. I'm going to throw this into the chat box. I will put it in the folder as well, but this is the link for you to have that document. And are these going to all be on the link? Yes, everything that we are showing you and everything that I have will all be on this slide deck. You will have access to all the links. You'll be able to go in and out as you wish. So what will happen, here's what I need you to write down, because this is not something I can cut and paste, so I'll just leave it up for a few minutes. This is the email or the where you need to just simply say where that you want to get a login to their website. And here are the 3 things that they need from you. They need to know what school board you are from. They need to know what school you are at. And they just need to know your email address. So those 3 things in that email using that address. And what you'll get is a welcome email, and it will look like this rectangle that you're seeing, and it'll have this blue button on there. And when you click on the blue button, you'll be in, and then you can go in and search. So you have advantage of being able to use all of the science stuff that's in there, and their science gizmos are written for grades 3 to high school. So there's a lot of them. We just have to be cognizant that we read them through carefully. If you've never done a gizmo before, then you should always make sure that you do the gizmo first before you go in and do it with the students. So it's not something you just throw up and just say, okay, we're going to do a gizmo today. If you've never done one and they've never done one, you should work your way through. The other thing is that they give you lesson assignments. They'll give you worksheets that go with them. There's plans for the teacher as well. You can edit those, and I would probably say you're going to likely edit them anyway, so you can download them as a Word document or a doc, and then just cut out the questions you don't want. They're fully editable, and that's the nice piece about them. Okay, so let's keep going here because we're going to run out of time. I have one set of general resources, so if you're just looking for some ideas for other experiments, these are they fit very well with what you're doing. Some of them are a little bit outside of it, but again, these are just some ideas to give you there. They're not something you have to do this time, absolutely. I'm putting in a couple of templates. This one might be something that you use as a formative or as a mini summative, depending on where you're at and what you want them to do to show you their knowledge and understanding. Some teachers have been asking for a rubric, and we don't have one at this point in time. So I've gone to the Ontario Ministry because theirs is a very tight fit to ours. So is BC, but BC has built their own competencies into it, and that makes it a little bit more confusing for us. And so the Ontario Ministry one is a little bit better, and it gives you, this is only just a snapshot of a part of the first page. So there's 2 pages or 2.5 pages to this that you could use as a consistent assessment tool if that's what you wanted to do. And then this is just the link to the Science Matters one that I showed you, and just the background that comes from it, because this is a very cool site, and they did a lot of work in research that came out of it, and they shared it with the teachers across their area. So it's a great little tool and place for you to go for resources. And again, just our resources here, just an FYI, there weren't a lot this time for grade 6 that I could find, but Pearson has opened their library to you. So if you are teaching other grades, and I'm saying there weren't any for this particular organizing idea. I'm not saying that there couldn't be for the future. They've opened up their library for a 30-day free trial. So if you wanted to go in and you were looking for some books, like mini books, you might want to just go in and just peruse them. You can go in, you can read the whole book, you can go from beginning to end, you can see the questions that are asked in it. So it's a nice little option if you had some things that you were looking for as well. And that's only if you're looking for other resources. Okay, that was a lot. So thank you for hanging in there with us. So we don't have a lot more to share with you because we already talked about the gizmos, and there are sessions. If you're not finding that that's working for you, there are sessions in January. that are starting in the second week of January. There'll be 3 a week. You can sign up for any one that you want. 2 are in English, 1 are in French. And those are just to do what I just showed you. Get a login from them, get a password from them, get into the site, and then they take you through. So that's kind of sort of the area that they want you to go to. Okay, so that's it for today, and we'll put all of that into the folder. Is there anybody that's left on that does not know where to find the folder? Just maybe throw it into the chat box, say, yes, I don't know, or I can go there for you very quickly. Okay, let me show you. So we're going to go to the moving forward. And if you're registered with us, which you all are, so you're here today, you would have received a login and a password already. I'm going to throw this in the chat box so that you can grab the link. And if you don't remember getting one, just type in your search bar in the top where your email is, just put in moving forward and it'll probably just come up and you'll get your login and your password. If not, you can always access it through create another one, but you shouldn't have to do that. So let's just I'll show you where it is. You're going to go to subject areas, and in subject areas, select science. And I'm just going to I'll pick grade 4 because I know that's posted already. So you'll see that the introductory one is there. So if you're brand new to this and you didn't do anything yet, make sure that you watch that session 1. That was not specific about a grade. It was for the same thing for everybody that's doing science right now. So have a read of that, and then you can also download these 2 documents if you didn't do that for your grade that you're doing. Session 2 is living systems. So the same kind of thing that we did there or here will be in living systems as well. So you'll always have the video will be there. And then if there's any documents, we always share the slide deck with you. If there's any assessment tools that we've got for you, we'll put them in here. If there's general documents, planning tools, like anything that we think will help, either shared on the video or we just know that it's there and put it there. So sometimes there's things in that list below that weren't even highlighted. You don't have to rush to go in and download all this. It's not going away. It doesn't go away at the end of the year. If anything, we'll just tool it up. And once we know exactly what the curriculum would look like, we'll add to it. We'll just tweak it. So you're good to go. You don't have to worry about what's there. Does that answer the question, I hope? Are there any other questions? Now, our question to you would be, I'm just going to stop the recording here so that we don't have a bunch of talk on it. There we go.